Right, to start our radical journey, if you would, let's begin by just taking a look at what a radical statement looks like. So, in general, mathematically, we write the radical like this. Verbally, what it means is the nth root of a. That's literally how we read that. So the nth root of a. The little number that's up in this kind of corner of, first of all, this symbol right here, this crazy looking symbol, is called a radical. So when you see that crazy symbol, it's a radical notation. Please don't confuse it with the division sign, because we're not dividing here. That usually that little tag that I have right here indicates that it's a radical, as opposed to the long division sign that would probably look like this. So this is long division, right? And that's my radical notation. A nice crisp little tail, if you would, and a nice crisp, how would you call it, corner or cusp, rather than a nice smooth one. So long division versus radical. So we now know we're looking at a radical. The little n, this number that sits right on top of that little tail, if you would, or right inside the crook of that arm, is called the index. And then the number that's underneath the radical, that's inside of it, is called the radicand. And like I said earlier, what it's called is the nth root of a. We'll talk a little bit about its meaning, but right now, with just that definition, let's take a look at some expressions and try to identify what's the index, what's the radicand, and essentially what's inside. So when I look at this first one, again, I see that symbol right here. And so the number that's in its little arm, if you would, the index in this case is 3, and the radicand, the item that's inside of it, in this case, would be x plus 7. So we're putting x plus 7, the expression, inside the radical that is being an index of 3. And we literally read this as the third root of x plus 7. So that little nth doesn't make sense here with a 3, but a cubed root. The next one, we have to be careful here. This 4 is kind of standing alone outside. So it's almost, well, it's not almost, it is. You can treat this as a multiplication problem. We're multiplying 4 to this radical expression. The radical is this symbol. What's underneath it is the radicand, and what's sitting right on the crook of its arm is the index. So in this case, the index here is 5, and the radicand is 7x. And again, we're actually multiplying here. This 4, it would almost be like following order of operations. I would have to figure out what this guy is first, get that value, and then multiply it by 4. Same thing with the next one. This 5 is not to be mistaken as the index, because the 5 isn't written in that little arm, if you would, in that little corner or the little elbow. It's off to the side. So quite literally, we're talking about another multiplication here. We're talking about 5 times what would be known as the square root of 11. When there is not a little index there, when you don't see a little number, it's understood that it is a 2. So we're talking about a square root, and of course the radicand in this case would be 11. Oh, by the way, I don't think I mentioned this. This is the 5th root of 7 times x. All right, there's how we would read that. I don't think I said that earlier. So we're talking about 5, right, times the square root of 11. And so that's what we would be doing there. Again, this one's a little confusing to look at. It's very typical of something we're going to see in our future. We have all these little powers everywhere. So the first thing is to realize that this x squared is an exponential expression all by itself, and that's a radical. So maybe some parentheses will kind of help us out. We're basically taking the exponential expression x squared and we're multiplying it to a radical. What's the index of this radical? It's 4. So we're talking about a 4th root. What are we taking the 4th root of? Whatever is underneath that radical. Oops, I think I miswrote it. So x plus 1 over y. So whatever's inside is your radicand, as you see, and whatever's sitting in that little elbow or that crux right above the tail is your index. And we're either talking about a cubed root, a 5th root, a square root, or another 4th root here. And again, be careful when there's something out in front of it. We might even have, like you'll see, some things being done behind it. And so we have to be really careful. Is this plus 7 part of the radicand, or is it outside of the radicand? And in this case, it's outside. And we'll talk more about that as we move around. But being identify who's who is really important. So now that we got that out of the way, let's take a look at its overall meaning. What in the world do I mean by all this crazy stuff? We'll come back and look at these a little later in chapter 10. But the meaning itself, what we are literally doing is we're doing the reverse, or what in some mathematical circles we call the inverse of a power. So when I see something like the square root of, let's say, 16, right? What I'm looking at here is I'm looking at some number that when I square it gives us 16. So this represents a number. It's a symbol for a number. It's the number that I raised to the second power to get 16. Now where did I get the 2 and the 16? The 2 is the index. So this is the radical expression, and this is the exponential expression. So radically what I'm saying is I've got a number, this represents a number, that when I square it gives me 16. And of course when you put your thinking caps on, and we'll talk about this in more detail, but one number that comes into mind is 4. So the square root of 16 is 4. If we had a cubed root, right? So the cubed root of, excuse me, of let's say 27. So again, the index is 3, so that's the radical notation, but exponentially I've got some number that I'm raising to the third power and getting 27. So that symbol represents a number. It's the number that I raised by 3 to get 27. And of course I think we know that to be 3. And on and on and on as this gets harder and harder. So the fourth root of, let's say, 16. So the fourth root of 16 is going to be different than the square root of 16 because I'm now representing a number, right, that when I raise it to the fourth power gives me 16. You might have to think a little bit more on that, but a number that does come to mind is 2, right, because 2 to the fourth, that's 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So the fourth root of 16 is 2. Because it's the number that I can raise raise to the fourth power and get 16. So we're literally reversing that. And on and on and on. It can get a little crazy. This is where calculators would probably come into play. But you know, if I was asking you for something like the square root of 7, this is actually a real number. This is not an it's a irrational number, as a matter of fact. It's not a nice one. It's an irrational one. And what we're asking for is some number that I can raise to the second power and get 7. And so you guys have to get used to the fact that this number actually exists. We're just not used to working with it too much. Without a calculator, I can kind of go through this. I know the square root of 9 is 3. And I know that the square root of 4 is 2. So the square root of 7, right, this is a number sitting between 2 and 3, and I'm going to say it's a little bit closer to 9. So, you know, maybe we say this is roughly, this number is like 3.7. And I could be a little bit off, but to be sure, right, I would just take 3.7 and multiply it. Oops, excuse me, how about I say 2.7? That's a little bit too high. 2.7, and just multiply it to itself, because that's what that means. And now you can really see, gosh, why don't we just turn to a calculator? So if you did do that, let me go to the one on my computer here. I should probably bring my phone over. But what I'm getting for the square root of 7, my calculator is giving me 3.2 points. So this number is 2.6. 4575, and it goes on forever. So this is the number that if I squared it, I would get 7. So again, be aware of the fact that there's a lot of not nice radicals out there. That doesn't mean they don't exist. Some do and some don't. This one does. In terms of the meaning, I can think of squaring something and getting 7. Alright, so how about I cut this video off for a moment. We're going to do the evaluations another one because we're already 10 minutes into this. But hopefully that's a good introduction, and we're going to use that to do everything that's on the bottom here.